Hi, my name is Alan Rodriguez and I'm going to introduce you to my physics project, Third Newton's Law. And now, Newton's third law says that any force applied to a body produces an equal and opposite force. For every action, there is a reaction. A shooter senses the recoil of the rifle against his shoulder when firing. The recoil force is equal in magnitude to that transmitted by the bullet. And now, in the movies, people fight off when shooting. This is somewhat misleading. If the force were great, the shooter would be thrown backward from the recoil, but the force on the ground is so small. But because the landmass is much greater than ours. And now it explains the generation of thrust by a rocket engine, where the hot exhaust gas is produced through the combustion of the fuel with an oxidizer. This gas flows through the rocket nozzle and is accelerated to the rear of the rocket. Using a balloon, we can observe Newton's third law and get an idea of how rockets work and the type of propulsion they have. When filling the balloon with air, the pressure inside increases. When releasing it, the pressure is released, moving the balloon to the opposite direction. And now, what is the effect of changing the side of the balloon over the distance traveled? Is the opposite force perceived as equivalent to the distance that the balloon moved? The bigger the balloon, the more air it will have inside, so the force will be greater and will reach a greater distance, which will be inversely proportional to the recoil of the balloon. And now, what was the procedures and the results I got? And all it was because the entrance of the balloon wobbles when the air leaves the balloon. Path will also do it. The air that escapes from the balloon will push everywhere, so the first problem is to stabilize it. For this, a thread guide will be used. Once the thread is mounted the trajectory of the balloon, it will be more stable. And now, the materials will be one balloon, close tape measure, 2 string of 5 meters for guide, masking tape, 2 straws, flexometer, 2 chairs, binder clip, and calculator. And now, the steps to follow are 9. And we're gonna start to the first one. And this, tie the rope to the chair that are 5 meters apart. Use a flexometer. Cut the straws in 3 that you can attach to the balloon with the tape. Inflate the balloon and seal the air by folding the neck and clamping with the binder clip. Measure the circumference of the balloon with a tape measure in the widest point, like figure 1. Tip a straw parallel to the nozzle to your inflated balloon. Pass the guide string through the straw attached to the inflated balloon. Tie the guide rope ensuring that it is aligned and there are no variations in height, for that takes the height of the 2 ends. Remove the clip from the balloon and record in the table the distance in which it stops completely. Repeat steps 5 to 10 4 times with balloons inflated to a bigger circumference every time. And now, analysis of results. The behavior of the balloon is given by the theoretical model since the force inside the balloon when released equal and opposite. Some flaws were presented when experiments, such as the lack of stability of the balloon and the slight variation of sizes in each of the tests. The lack of correlations that were presented were due to human error. The results obtained coincide with the other investigated practices with the same principles and characteristics. The importance of the result obtained is that we can observe something amazing like the operation of the rockets in a simple practice. The results show that Newton's third law will always be fulfilled at least on planet Earth. Now, conclusions. The increasing the volume of the air in the ball made it reach a greater distance because it can push more, allowing them to exert force for a longer period, as predicted by Newton's third law. For every action, there is an equal and opposite reaction. Thanks to this experiment, it can be determined that the theoretical model works and it's correct. The experiment went as planned, and I advise using high-quality clips so that they do not come off until you decide. Tighten the string well, and especially that it is completely straight. Center the straw well on the balloon to prevent the pressure from pushing it from different directions.